Welcome to another Math Ninja Pro video.
In this video, we will learn about stem and leaf diagrams, how to read them, as well as their advantages and disadvantages. This is the raw data of the masses of 30 students. To make sense of the dataset, we need to start by organizing it. Let's start by arranging the data values in ascending order. Now let's proceed to organize the data from the table to form a stem and leaf diagram. A stem and leaf diagram is a statistical diagram that is used to organize numerical data. It consists of a column for the stems and another column for the leaves. To construct a stem and leaf diagram, we need to extract the more significant digit of each mass, which is the 10th digit, to form a stem. Since the mass of these students range from 39 to 71, the digits in the stem column of the stem and leaf diagram are 3, 4, 5, 6, and 7. The stems are arranged in ascending order in a vertical column. Next, we proceed to extract the 1st digit of the masses as a leaf. Each leaf is placed in a row corresponding to its stem in ascending order. Note that commas are not used to separate the leaves, and the total number of leaves must be equal to the total number of data values in the table. In this case, there are 30 students in the dataset, so there should be 30 leaves. Finally, we complete our stem and leaf diagram with a key to indicate the place value of the stem and the leaf. Now let us take a closer look at this stem and leaf diagram to learn how to read information from it. First, there are 30 leaves, so that means that there are 30 data points. In this case, it means that there are 30 students in this dataset. Next, there are 10 leaves in the row corresponding to the stem 4. This means that there are 10 students who are 40 plus kg. How many students are at least 60 kg? Counting the leaves in the rows corresponding to the stems 6 and 7, we can see that there are 6 plus 2, which is 8 students who are at least 60 kg. We can also easily tell that the lowest mass is 39 kg and the highest mass is 71 kg from this stem and leaf diagram, since the leaves have been arranged in ascending order. We call stem and leaf diagrams in which the leaves are arranged in ascending order an ordered stem and leaf diagram. What if we want to split the dataset into two groups, one for the boys and another for the girls, so that we can compare the masses of boys and girls? Well, we can do so by constructing a back-to-back stem and leaf diagram. This is how the back-to-back stem and leaf diagram for the same data set will look like when we split the data into two groups, one for the boys and one for the girls. The key shows us how we can interpret the stem and leaves for both groups of data. Notice that the leaves are arranged in ascending order from the stem. This means that the smallest leaves are nearest to the stem for both the boys and the girls. After splitting the data into this back-to-back stem and leaf diagram, we can easily tell that there are 16 boys and 14 girls in this dataset simply by counting the number of leaves for the boys and the number of leaves for the girls. Now, with this back-to-back stem and leaf diagram, we can tell that the student with the lowest mass is a girl, and she weighs 39 kilograms, and the student with the highest mass is a boy, who weighs 71 kilograms. Hence, one advantage of a back-to-back stem and leaf diagram is that it enables us to present two groups of data in a single diagram to facilitate comparison between the two datasets. It also retains the original values of the dataset, and the values are arranged in ascending order. Thus, it will show the maximum and minimum values of the dataset clearly. And stem and leaf diagrams also show the distribution of the dataset. For this dataset, we can see that the girls are mostly 40 to 50 plus kg, while the boys are mostly 50 to 60 plus kg. Here is another stem and leaf diagram showing the heights of students in a class. Notice that there is only a few stems and many leaves in one stem. When there are too many leaves in one stem, we can represent the data using a stem and leaf diagram with split stems. Notice here that we have split the leaves for the stems 15 into two groups. The first row is for the data values between 150 and 154 inclusive, and the second row is for data values between 155 and 159 inclusive. Similarly, the leaves for the stem 16 are also split into two groups for data values between 160 and 164 inclusive, and for data values between 165 and 169 inclusive, and so on for the stems 17 and 18. Even though we can construct a stem and leaf diagram with split stems, when there are too many leaves in one stem, stem and leaf diagrams are not suitable for data sets that are too large. Imagine if a data set has 500 data values. We will need to have 500 leaves. Stem and leaf diagrams are also not suitable for small data sets with too large or too small differences between the largest and smallest values, as it may be difficult to define appropriate stems. Imagine if all the data points are between 160 to 179 inclusive. Then we will only have two stems, 16 and 17. Even if we split the stems, we will only have 4 stems. In summary, in a stem and leaf diagram, each data value is represented by two parts, the stem and the leaf. The leaves are arranged in ascending order from the stem. A key is always included to indicate the place value of the stem and the leaf, so that readers can interpret the stem and leaf diagram correctly. When we want to compare two datasets in the same diagram, we can represent the datasets using a back-to-back stem and leaf diagram. When there are a few stems and too many leaves in one stem, we can represent the dataset using a stem and leaf diagram with split stems. Like all other statistical diagrams, there are advantages and disadvantages when using stem and leaf diagrams to present data.
Remember to like, subscribe, and keep coming back for more Ninja level math videos.